Hi, right, I'm going to do another video. Sorry this is a bit out of focus and I'm quite large in the video, but the problem is my camera will not sort of focus on sort of other things once I've started it going, so it's a bit silly, so I had to set it all up to start with. What I'm going to do this time is I'm going to check video RAM. Now I've had a lot of bother because I've been trying to get this tester to actually read and write to video RAM recently. And you can do it with software. I know there's a chap out there who's actually done it with software. His code is extremely clever and quite complicated. Well, I've done it a different route. I've done it with a little bit of hardware, which suits me basically because it's the way the tester works. I think hardware is better for my application here. But anyway, it's now working with video RAM, so I can read and write to video RAM. The problem with video RAM is it's not only accessed by the microprocessor, it's also accessed by the video circuit on the arcade board you might be testing. So you only have a certain window to work actually in the window. You only have a certain window that you can access the data from the video RAM, so you can only read or write it, but you can only do it at a certain time period, and that's quite critical and it's quite tight. So the tester will actually do it. Now one thing we can do is I have my Pacman board, which unfortunately is now not working due to a fault of my own. I made a stupid mistake, but there you go, we won't go into all that. But I've got 3 banks of video RAM on this Pacman board, and now I've actually got in front of me a memory map for the Pacman board, so it tells me where each bank of memory is, and they're typical 2114 RAM chips. There's obviously 2 per 8 bits because each one has 4 bits per chip. So what we're going to do is, I know there are actually faults in the video RAM, but what we're going to do is I'm going to check them, and I'm going to show you how to check them with this tester. Okay. Now the Pacman board is on the bench, it's exactly as it was before, it's hooked all up, so there's no need to really show you that again. But what I will do is I'll show you the screen, which will actually show you what I'm doing. So I'm going to pan it around and let you see what's happening here. Now there are some alterations to the actual test software, but I wouldn't go into that for the moment. This is an upcoming revision of the software that I've done and made a few alterations to it. So you'll see when it starts up, hopefully, the camera has actually focused on it this time, which is quite amazing. And you can see on there it's booted up. I'll move this a little bit so it's square because I haven't got a very good setup here, so you'll have to bear with me. But so we have the typical main test screen which comes up when you start the tester. On this one you can actually see that it's coming up with the AOS software revision number, which the old version of software never did. So apart from that, it's exactly the same. There's a few extra buttons down here and there which we'll just ignore for the moment. It's set up for a Z80 because the Pacman is a Z80 system. Okay, and what I'm going to do first of all is I'm going to turn the Pacman board on. You won't see that happening, but trust me, it is actually now powered up. I can actually show you the board. Ignore all the mess because it is a complete mess. There's the Pacman board down there, as you can see, and the video RAM, if I can show you, are these ones here, which is where we're going to test them. Okay, just ignore it because my tester looks like it's exploding into millions of bits, but it's because the one I was using unfortunately has been sold, so this one is the next one and it's getting tested, so I'm using it for developing and testing at the same time. So there we go, that's our test screen. Okay, I'll turn this light off and that might be a wee bit better. Right, the first thing we're going to do is we're going to check the the reason I'm going to do this is I know the first bank of video RAM has got a fault, but we'll show you this actually in action. So the first thing I'm going to do is I'm going to set the address to the second bank of video RAM, which will be on a Pacman board 4400 hex. And because it's a 2114, we can set the amount of bytes to 3FF, which is the full 1K of video RAM. Now at the moment that's just set for the address and it's set for the number of bytes, and the data I've set to 0. Now if I do write address, the tester will load in address 4400, so it's now set to that. And if I do a block read, it will say reading data, please wait, and you'll see the data come up. Now bear in mind this has just been turned on, so the data will be all garbled and rubbish. And as you can see, it's all garbled and rubbish, and the address is over the left hand side. So there's the address and this is the data, and there's 16 bytes per line. And if you go right the way up to the top, I'm using my mouse wheel to scroll, by the way, you can see it starts at 4400 and that's all your data. Okay, so it's created a text file as well, but we'll ignore that. So what I'm going to do is I'm going to put the address back to the beginning again, which is 4400, and this time I'm going to write in 00, so I have to do a block write this time. And it's a block fill writing data, and it says block data loaded 0, next address 48. So that's the next address the tester would go to if you wanted to do something. So at this point it's loaded 00 into all those locations in the VRAM. Do a write address, put it back to the beginning, and we'll do exactly the same again. We'll do a block read and you'll see the data has actually been put in, just to prove I'm not kidding on here and I've got something rigged up. So as you can see there, the data is now all 0. And that will work with any byte effectively. Now the cool trick we can do here, and I've already stored this, is I've actually stored that as like a ROM effectively. So I've stored that block of data in it, and it's created a CRC for that data and it's stored it. So now if I do that to put it back to 4400 and I do an ID check, it'll read it in and it'll then compare it, and if the RAM is good it will come back and say 2114 RAM filled with 00. Put it back to the beginning, and on this occasion we'll also do something different. So say let's put in FF, right? We'll keep the bytes exactly the same. That's set to 4400. Do an ID check again. What it's doing this time is it's looking for data that's all FF, and it's failed it because it's come back and said it's filled with 0. And the reason being is we didn't load it in. So let's load that in, do a block write. This just proves this actually does it, because you know, it's one of these things that you could say you do it, but unless you actually show it happening, people probably won't believe you, right? So there it's loaded in FF, and on this occasion we're going to now do an ID check. Now I keep going back there to put the address back to the beginning each time, so that's why I'm going up there all the time. And now you can see it says 2114 RAM filled with FF, and we can actually prove that if we actually go and do a block read. You can see it's actually quite quick as well, because bear in mind that's 1K of memory it's loaded, and you can see it's all FF. Right way up to the top, there you go, that's where we started off, you see. And if you go further up, that's the data when it was all 0. So you can actually go up and down all this information all the time. Now on this next occasion I'm going to change it to EE, just to give it another test. So we've set it to 4400, do a block write, we'll load in EE, and here we go again, it's loaded it all in. Do an ID check, and if we're lucky it's told me it's filled with EE this time. So that's proved that bank of RAM is fine. So let's go to say the first bank of RAM which I talked about, which is 4000 hex. Now on this occasion there is a problem, so there's either a bad pin, a bad connector, or the RAM itself, but we'll do exactly the same again. Type in 00, do a block write, and it's done it. Now we're going to do a CRC check, an ID check again. You can apply this to any block, it doesn't matter what address it starts at, it works on the amount of data, so the bytes are still going to be set to 3FF, but we've changed the start address on this case. So we do the same. Now if the RAM was absolutely fine, it should pass and come up to say that, but on this occasion it's not, and the RAM is faulty because it says checked against all the files, 2188, no match for board found, enter game info or enter game info or enter to skip. I don't want to